Okay, so welcome to our session today. And our today's session, we're going to discuss about inferential statistics. Inferential statistics. So inferential statistics, in other words, is different from descriptive statistics. We have two types of statistics. We have inferential statistics and descriptive statistics. Descriptive statistics is where we look at some things like frequency, proportion, distribution of data, things like summary statistics. What is the mean? What is the median? What's the mode? And we also go ahead and build some visualization, exploratory data analysis. And then now from exploratory data analysis, we should be able now to make decision with the data. So for us to make a decision with the data, we need something we call inferential statistics so that we can infer, we can make decisions based on the sample data that we have. So today, we have a privilege of discussing about inferential statistics. We are going to discuss about correlation. I don't know if you've ever heard about correlation. And then we are going to look at regression. We're going to look at regression. And then after that, and when time will allow, we are going to look at hypothesis testing. Hypothesis testing, that is, we are just going to focus on one sample t-test, paired t-test, and unpaired t-test. We are going to discover all this. If you are not familiar with any of the things that I'm mentioning, don't worry at all. We are going to ensure that we all understand all this stuff that we're supposed to understand. Okay, so having said that, maybe I can listen to you, colleagues, if you have ever heard of correlation before we start our session today. So let me just stop sharing, and then I just want to listen to us if you have ever heard about something like correlation. Anyone, you can just raise your hand and tell us maybe what do you think correlation is. Yeah. Just raise your hand. Yes, Faith.
Correlation is like a connection between two either factors, or it can be two items which can either be positive or negative.
Okay, Faith. Okay, thank you. So we clap for you. We clap for you. Thank you. So that's Faith. Is saying that correlation help us to know the connection between two factors. It can be two variables or two features. Other time we usually use features when it comes to feature engineering. So I don't know. Yeah, someone else, if you have something about correlation, you can just raise your hand and maybe tell us, what do you think correlation is? What do you think correlation is? You can just raise your hand and maybe tell us, what do you think correlation is? Yeah, so if you're listening to correlation for the first time, we have something we call causation, and then we have something we call correlation. So correlation is a technique that helps us to understand the association, to understand the relationship between two variables, We usually call them variables, or you can call them factors, or you can call them features. So it helps us to know if the relationship between these two variables is positive or negative. So positive meaning that as one increases, another one increases as well. As one decreases, another one decreases as well. For example, as revenue increases, we are likely to, the profit is likely to increase. You see? So that is a correlation. That is a relationship. There is a relationship. So while discussing about correlation, we have something we call R. We call Pearson R. If you have never heard about Pearson R, this is a statistic term, a statistic value that we usually look at to check how strong, to assess how strong is the relationship. You know, we cannot just say that it is positive, it's negative. We should know how strong is it. So that we can now say it is positively strong, or we can say it is negatively strong, or we can say it is positively weak, or we can say it is negatively weak. So that those are some of the things that we are going to discuss here in today's session. Yeah, so we are going to have an interactive session. So let me again proceed now and share my screen so that now we can be able to proceed from there. So if you cannot be able to see my screen, you'll just let me know so that I don't talk while not presenting. So this is Microsoft Excel, and I want to share this data with all of us so that we can, you can even later as well be able to follow along. So let me just share this data with you here in the chat section before we proceed, because it's good when you have the data as well, so that you can also tell me, oh, right, I'm also getting the same as what you have, rather than me having my things and you also have your things. So here's the data set. I'm sharing it in the chat section, and also the data set for the previous sessions, you will get it. We have a feedback form where you'll be able to fill, and we will send you the data set if you don't have. But this data set I have shared here, just click on it, it will be able to download. This one is the data set that will enable you to have our session today interactive. So just click on that data, it will be able to download to your machine. For the data set for the previous sessions, let me just trace it here for the dashboard so that you can also work on the dashboard later, dashboard data. So I just want also to paste that in the chat section so that you can also work on that, later after the session. So the dataset for today's session is the one above, and then the following is the dataset for the previous sessions. Yeah, so I have shared the second data for the other one about amount, about profit, country, and so on. So you can also get it in the chat section. Yeah, so I can now proceed. Hope it is downloading a data set known as data analysis using Excel dataset. Can someone just react to me if you can be able to get that data, the one at the first one? Okay, thank you, Faith. If you can get the first data, please confirm that it is data analysis using Excel dataset. So I can also now proceed and now share my screen so that we can start working on the data. Because time is not on our side. So I'll start sharing my screen. So this is the data set we are going to discuss. So this data set is about health. You know, when you become a data analyst, you need to be able to analyze different data scenarios. So in the previous sessions, we've been talking about business, sales and prices, and things like profit, revenue. So what if you are interested in the health field? So how can we use data analysis to be able to help us do that? So in this scenario, we want to start by looking at correlation. So this data is about health data. So you can see patient ID here, the patient gender, patient age, pre-surgery score, pre-surgery health score, physical therapy duration, and medical adherence score. Yeah, like these values range from 0 to 10. This value ranges from 0 to 10. This cost ranges from 0 to 10. So pre-surgery health score, someone before going to surgery, we may want to know, yeah, how healthy is the person from 0 to 1, from 0 to 10. Yeah. And then from there, medical adherence is after pre-surgery, after surgery. Now we want to know from 0 to 10, from 1 to 10. Let me talk about 1 to 10. how likely are you adhering? How likely are you adhering to the prescriptions, to the medical prescriptions? Eh? So when you are given 10, that means that you really follow the the procedure that was given for taking the drugs. And then recovery time. So we want to check if there is a relationship between medical adherence and maybe recovery time. So we want to know maybe someone who had the highest medical adherence maybe had a shortest recovery time, you see, in terms of days. So this is some of the things that now we bring to life, and maybe we can now assess that using correlation. So I wanted to know if you have your laptop with you, because some of the things here that we are going to use today, you don't have them. You don't have them already. Yeah. So for you to enable that, I just want us to confirm. Go to your data tab. Go to your data tab. If you have Excel, go to your data tab, and then check if you have data analysis tools. Go to data tab and then check if you have data analysis tools for financial and scientific data analysis. Just confirm that before we start our session. If you don't, I will ask one of us to share their screen, and then I'll be able to guide you on how you can enable this, because without this, you cannot be able to perform things that we are going to perform here today. You cannot be able to perform things we're going to perform here today. Yeah, so maybe I can check if we have this. Can I see a reaction? If you already have that data analysis tool pack with you, can I see? Faith, do you have?
I don't have my laptop.
Okay, okay, okay. So if you look at our previous videos, you will be able to see how we enabled that. So just in case you get your laptop, you will see how we enabled that. So you have to go to files, then go to more options. Yes, there's someone. You can unmute, please. Unmute, please. That is Dida. Do you have your laptop?
Yes, I do have my laptop.
Yes. Can you share your screen, please?
Where's the tab for sharing the screen?
There is a tab like upload, present now. When you hover on it, it's called present now. So from end call, from leave call, you
Present
go
now,
to,
yeah.
yeah, click on present now.
Uh-huh.
And then now you can go to entire screen. Go to entire screen, click on entire screen.
Yeah.
And then you click on the image you will see. Yes. You click on that
Is it
image.
sharing?
Yeah, it's sharing. Thank you.
Uh,
Yeah, thank you. So just dismiss that, and then now go
mhm.
to your Excel. Okay,
So this
that's
is my
nice.
Excel file.
Yeah, nice, nice. So
Uh,
when you go to data, yeah, it's not there yet. So
mhm.
we need to help you be
Yes.
able to enable that. And I think majority of us will learn from that. So you have to go to file. You have to go to file. Go to file, and then go to
Mhm.
options. Go to more. Go to more down there, and then go to options, and then go to add-ins, go to add-ins, add-ins, click on add-ins, then scroll down, go, click on go, click on go.
Well,
There's go down there.
oh yeah. Mhm.
Yeah, click on go. So analysis, check analysis toolpack. Just check
The first
analysis
one.
toolpack. Yeah, the first one. And then
Mm.
click on OK. And then click on OK. So
Oh,
you
thank
see,
you.
there
Yes.
you go. There you
Uh,
go. There you go. Yeah,
can I
anyone else?
can
Yeah,
I
you can
stop
stop.
sharing?
You can stop sharing. Thank you. Thank you, Dida. Yeah, so that's how we enable data analysis toolpack in Microsoft Excel. Anyone else with the laptop? So Dida, you will be the one who will be sharing if you want you to share your screen. Good luck that now you have your laptop. At least we can have an interactive session. Yeah.
Wait. Okay.
Yes. Anyone else? Anyone else with a laptop and you don't have data analysis toolpack? Just go to your data tab and then go to the other far end, and then you'll be able to see that. If you don't have, you please let us know so that we can work together through this journey. So let me again now, yeah, start sharing my screen, entire screen, and then yeah. So once you have the data analysis toolpack here, so when you click on it, when you click on the data analysis here, it will be able to open this dialog box. So in this box, you can see we have correlation here. When you scroll down, you can see descriptive statistics, some things like analysis of variance. You see now you can be able to carry out inferential statistics, pretty cool. You can see we have F-tests. You can see we have things like regression. You can see we have things like t-tests, yeah, t-tests, and so on, and so on, yeah. So we want to start by looking at correlation. So just click on correlation, go to data analysis, click on it, and then go to correlation, click on correlation, and then click on OK. Click on correlation and click on OK. So maybe we want to assess the relationship between medical adherence score and maybe recovery time in terms of days. Yeah, so maybe you just want to understand, is there any kind of relationship, yeah, between these two variables that we have? So you just click here under input range, and then you can click on this button, upload button, to enable you, to give you a space for you to select the data. So you'll select the data, including their headers, like this, up to here, like that, up to here. The data is made up of 30 observations about patients, and we just want to understand. This is just an example for learning. It does not have any implication on anyone's health. So it's just purposes of learning. Yeah. So yeah, you can unmute, please. I can see someone's hand. Yes.
The settings after you select correlation, what do you put in the input range and stuff?
Okay. In the input range, you click on
Yes.
this icon. You can click on this icon. Do you see this icon for upload? You click on it, and then you come here to medical adherence scores. So you select this range, the range of this data, medical adherence score and the medical and recovery time days. So you select all this data on your left click. Let me just delete this and repeat the process. So you left click, you click on medical adherence score, left click, drag by selecting. By that, you'll be selecting up to where? At the end of the data. And then you release your selection.
Okay, thank you.
Yes, and then you click on this icon to go back to the dialog box like this. And then, yeah, from here now you must check here that labels in first row. Remember, first row contains the names for the columns. The first row for the data range contains the names of the columns. So you have to check here labels in the first row. Remember, in the first row is where we had names. In the first row of this data range, that we selected. So you must check here. And group by data is grouped by columns. That's why our data is going down. And where we want to see outputs, you come here now. Output options, output in the range. We don't want a new sheet, just change to output in the range. And then you select where we want to see our output. So maybe we just want to see our output. So you click here, you click inside this cell, output range, you click inside this text box. And then you click on maybe this upload icon as well to minimize that and give you an opportunity for you to go at the top where you want to post your results. So maybe I want my results to be here. So I just select here like this. I just want my results here. I also select here like this, where I want to see my output. and then I can click on this download icon for it to return me back here. So I have uploaded where my output will be, and then from there I can click on OK to see my results about the correlation between medical adherence scores and recovery time. So just click on OK here like this. And then I can see now I have my results here. I don't know if someone is getting results like the ones I have. Don't know. Please confirm. Yeah, you can unmute.
Hello.
Hello.
Can you share again the data set and someone else is also requesting you repeat the procedure?
Okay, thank you, thank you. So let me reshare again the dataset link for this session. So for me to stop multiple screens, I'll just stop sharing and then I'll post the data and then again I'll share the screen. So don't worry anymore. I'll repeat the process until we can understand. So let me just reshare the data again. The dataset link is called dataset here. So let me reshare the data again. So here is the data set. Here is the data set in the chat section. So when you click on the link, it will be able to download the data right away to your machine. So what we'll just have to do is to open the data, and then you can now go to your Excel. And then from there, you have to enable a data analysis toolpack in Excel, the way we did for DIDA. Just in case you have your laptop and yours is not yet enabled, please let us know so that we can guide you. So you come to Data tab and then check if you have Data Analysis toolpack here under Analysis ribbon. Under Analysis ribbon, check that you have Data Analysis. If you don't, please let us know. So the procedure is simple. You click on the data analysis, and then you click on correlation. We are starting by checking the relationship between medical adherence scores and recovery time. So you click on correlation, and then you click on OK. You click on OK, you'll be, for me, I already have existing history data about procedures that I did, but now I'll repeat by deleting everything here. So input range, we are selecting medical adherence score and recovery time. We want to understand if there is a relationship between someone adhering to the drugs, like taking drugs, if you are prescribed to take drugs in the morning, in midday, and in the evening, you need to follow that. And now we need to know, yes, someone,
Excuse me.
yes.
Are you sharing your screen? I can't see your screen.
Okay, sorry. Okay, thank you. Agnes. Agnes is my colleague. Yeah, thank you, Agnes, for reminding me that, when you stop sharing and sharing and sharing, you can happen to forget. That I'll repeat the process. Yeah, so we said you go to the data tab here, and then you go to data analysis. So if you don't have this data analysis toolpack, please let us know so that we can repeat that as well. But if you already followed what we did with data, then we are good to go. So you click on data analysis here, and then you click on correlation, and then you click on OK. Right? So for me, I had already history data here, so I'll have to delete this history data to repeat the process. If you're doing it for the first time, you'll not get those information. So just click here, input range, and then you click on this icon to enable you to go to the range you want to select. So for me, you start from medical adherence score, recovery time day, and then you drag, select everything up to down here at the end of the data. So the data is of 30 observations, and then you click here to go back to the dialog. You click here like that. And then once we have this, we come here, our data is grouped by column. That's why we are going down. And then you must check labels in the first row. That means that the first row from the range of our data is containing the titles. the way we did. And then from here, you will see new worksheet. So change this to output range so that you can not open a new worksheet, but you can have your output on the same worksheet. And then you click on this icon for upload, and then you now go to where you want to see your output. You can put anywhere. I had already placed here, so I can place here again. So you select where you want to see your output like this, and then from there you click on this icon to go back like this. And there you go. Then you click on OK to get your results. I don't know if we are together up to there. Are we together, colleagues? Are we together? You can show me by a thumbs up if we are together up to that point. Okay. Thank you. So we can proceed. So the output we see here is correlation output. So we said correlation shows as association, how association, the relationship between two variables, how two variables are associated to each other. The correlation value, which we talked about Pearson R, ranges between -1 and 1. So -1 being strong negative, that is to the left. +1 being strong positive. So when the value tends towards the +1, we say it's a strong positive correlation. When the value, this value you see here, where these variables intersect, where they intersect with each other, here. And then you ignore this one because this one is a relationship between a variable and itself. So this is not a relationship. So you ignore this diagonal and you consider this. So the relationship between medical adherence and recovery time is negative relationship. What does that mean? When one increases, one decreases. So medical adherence score value ranges from 1 to 10. And the recovery time of days, it is a continuous value that we cannot say that it ranges from this to this. So it is just number of days. So we are trying to understand, like after surgery, when you adhere to your drugs, the drugs that you are prescribed by the doctor, take them at this particular time, you adhere. And then we give you a score based on your adherence from 1 to 10, where 1 is the poorest performance. And then we have 10, which is best or excellent. And then number of days. So that means that when someone takes, there is that negative relationship. That means that when someone adheres to the drugs, is likely to have less recovery time in terms of number of days. That's what we mean by negative relationship. So this is the Pearson R value. This value is towards 1, is approaching 1. So any value that is beyond -0.5 is said to be a strong negative relationship. Any value that is beyond 0.5 is said to be strong positive relationship. Any value below that, ranging from 0.00001 to up to 0.49999 is said to be weak. Similar, weak either negative or positive, depending on which symbol does the value have. When the value is 0, it's said to be no relationship between the variables. There's no relationship between the variables. However, as we discuss about correlation, we have something we call causation. So every correlation is not causation. Like variables being related does not mean that it has a direct influence, a direct impact. So you need to be very keen while making decision with the correlation. Maybe the reason as to why someone is recovery time is less when someone medical adherence is high is maybe because of maybe the age of a person. Maybe the person is still young, the blood is still flowing. Anyway, I'm not personal. Yeah, so yeah, so we need to understand that causation is not correlation. So correlation is just, oh, there is, when this increases, this decreases. But now causation is where we have a direct impact, direct influence. Anyway, we want to visualize this data using a scatter plot. We usually assess the direction of relationship if we want to see the trend, like when this increases using a scatter plot. So that's what the plot we use to check for association between two variables. So we want to plot a scatter plot. So for us to plot a scatter plot, we can put, you have to select your data, leave out the first rows, this title, the header, select the data from 9 and 14 down to 8 and 16. After selecting that data, go to insert. After selecting that data, go to insert. And then after insert, you can go here to insert scatter. Under charts, insert charts, go to insert scatter here, and then click on this drop down. Click on this drop down, and then you come here. So you click on this, the first one. You click on the first chart that you will see. So that first chart icon is the scatter plot that we are going to use. So maybe we can just drag this to the top. Let me see. My laptop is running a lot of things here, but yeah, it's now moving. Yeah, it's having a lot of things anyway. I'll just close them. Everything is already up. Yeah, so let me drag that again. Yeah, so there we go. So here, chart title, you can change the chart title. We did data visualization in the previous sessions. So you can also learn more about charts on our previous videos on YouTube. So maybe this is physical, this is what medical adherence score versus medical adherence score versus recovery time. So maybe if you need all this information, you can show them on the chart titles, axis titles. So you click here on add chart elements, you click on add chart titles like this, and then you come here to the x-axis, come to the x-axis, and now we can see x-axis is medical adherence score, medical adherence score, medical adherence score, medical adherence score. So that is on the x-axis, medical adherence score, and then on the y-axis is recovery time, recovery time, recovery time, recovery time. Yeah, like that, in days, recovery time in days, like that. Once we have that, hope we are together up to there. Hope we are together. Agnes.
Yes, you're together.
Okay, thank you. So we can now change the colors here. Maybe we change the font color here. You go to home and then you go to this font color here. You can change the color to be more readable from a distance. You can also change for this one as well, like that. And then you can change this one as well. So you can even see that how our visual is. You can see how the trend of our data points is. We can just add here a trend line to depict this value. Is a negative relationship. That's why when one increases, one tends to decrease. So that's what we see here. If one increases and one increases, it's supposed, all these values are supposed to be in this trend, moving from this to this direction to this direction. But when it happens to be like this, it is called a negative trend. When the values are on a straight line, we call it no relationship. So this is a scatter plot that helps us to do that. So you can add a trend line. You check here. You go to add chart title. You go to add trend line. So you can see when the trend line is here. And now from here, this one will lead us to simple linear regression by adding here a model. We are adding here a model. So we will go to more options here. Here we will go to, you click on this, and then you will see more options here. So click on more options so that we can add a simple linear regression model for this for this correlation scatter plot. And then from there we will see what next. So you click on more options, and now you will see. So sometimes your data may not be straight. So you may see this one is curved. When it is curved, you can be able to change trend lines to understand which model fits the data. Which model fits the data. You can see which model fits the data. You can be able to change and be able to understand which model really fits the data. You see? So for our case, it's linear. The data is linear. That's why linear becomes the most appropriate model for our case. So you scroll down. When you scroll down, you'll see display equation on the chart. So we want to display an equation on the chart. So you click on display equation on the chart, and you can see now we have an equation here. And then we can also display R squared value. We can also display R squared value. We are going to talk about all these things, what they mean. So wireless, if you are encountering this for the first time. So this is what we call data analysis. So you're trying to see if we can be able to predict recovery time of someone based on the medical adherence score. Of course, our model cannot be that accurate as such because it's only one variable, which is simple linear regression. We are going there. And in simple linear regression, when our variable does not really predict well the dependent variable, yeah, I've already mentioned the dependent variable, so we are going to discuss that. Yeah, so this is our scatter plot. So you can just take this somewhere else, like here. You can just click on it and then drag it, put it somewhere else, like that. Yeah, so there we go. So this is our scatter, showing us the trend relationship between these two variables. It's a negative relationship. So the Pearson R squared, Pearson R value 0.89. So this one tells us that there is a strong negative relationship between medical adherence scores and recovery time. So when medical adherence score increases, recovery time decreases. When the recovery time increases, medical adherence score decreases. And now we have a model here. So this model, we can use it to predict the recovery time. That is now the essence of regression analysis, regression model, to help us be able to predict what is going to happen based on what historical data that we have. And then we have something R squared here. This one now tells us the coefficient of variation. It tells us that 80%, we usually convert this to percentage by multiplying by 100, and then we say 80.13% of the dependent variable. Dependent variable in this case is recovery time. Recovery time, because it's the one that we are predicting, in this case, based on this model that we have. So 80.13% of the data has been explained. 80.13% of the dependent variable has been explained by independent variable. So to relate to this, we say 80.13% of recovery time has been explained by medical adherence score. And that is really nice. If our model can be able to explain 80% of the dependent variable, then that is a good model. That is a good model. Okay. So hope we are here. Unless there is a question, we can be able to proceed to simple linear regression. Is there any question from anyone? Anyone who is stranded? Let me just check if we are together by seeing reactions in the call. Can we see some reactions in the call to show that we are together? Okay, okay. Thank you, thank you, thank you. Okay. Yes, Dida. Yes, Dida, you can unmute. We cannot hear you if you are talking. You can unmute, please. Okay. For us now, we will just have to proceed now that we cannot be able to hear you, Dida. But just in case, let me just stop sharing and maybe check in the chat section. Sometimes people usually send messages in the chat section.
It was a mistake. It was a mistake. You can proceed.
Okay, Dida. Thank you. Thank you. Let me just check the chat section if everything is good. Okay, okay, okay. Thank you. Thank you. Okay, so we can proceed now. We can now proceed I'll start by sharing my screen again. So we are going to discuss about simple linear regression. You see, correlation has led us to simple linear regression. So we need to understand simple linear regression. So what is regression? Regression is a machine learning model. Regression is a machine learning model, or we can call it a statistical technique that is used to help us predict the outcome based on what we have. So regression depends on the historical data that you have for you to be able to predict the future of what is going to happen. So let me just take this output somewhere, just here, and then we discuss about correlation here. So not correlation, simple linear regression. So regression analysis is divided into two main categories: linear regression and nonlinear regression. This is just background. I'm just talking about the background of regression. And then from linear regression, we have different models for simple linear, for linear regression. So we have different models, but again, it is divided into different categories. So for linear, we are talking about simple linear regression, which only involves one dependent variable and one independent variable. Like in this case, you see this model that we have here. This one is already a simple linear regression model. This y is equal to this. So this is built from our linear algebra knowledge. Not even linear algebra, it was what? Things to do with the straight line in high school. Straight line, what straight line, what straight line? This is mx, mx, mx. Yeah, from y is equal to mx plus c. That's what this model is doing. Yeah, where y is the equation of a straight line, in short, equation of a straight line. So y is the dependent. I don't know if we were calling that during that time in high school or yeah. So y is the dependent variable. We did not use those terms anyway. But y is the dependent variable. M is the gradient. It was the gradient at that time. Yeah, the slope. And then we have x. X was the what? The independent variable. So we are using independent variable in this case. I cannot remember the names we were using that time. And then C is the intercept. C is the intercept. by that time. And then we call it here a constant. But again, we usually sometimes just call it intercept. Yes, just intercept. So this is the constant. You can see it is 40.708. And then m is the coefficient. In this case, m is the coefficient of x. Our knowledge here, leave alone the gradient and stuff. So it's the coefficient of x. Is the coefficient of x, this value. And then we have y. So this is a simple linear regression background, a line of an equation of a straight line. But we usually amend it to something like y is equal to a plus bx. A plus bx. Like this. Let me just, okay, I cannot maximize my view because I am already in the, my cell is active, I'm typing in it. Yeah, so let me, I will be able to zoom that later. So this model is this, where A is the constant. Sometimes we usually interchange A to start or BX to start because addition is commutative. That is the knowledge of discrete mathematics and what and things like mathematics, some other mathematical units. Yeah, so you can interchange, but it will not have any impact on addition. Like adding 5 plus 1 is the same as 1 plus 5. Yes, that's what we mean here by commutative property of addition symbol. Yeah, so we can now proceed. So here, we want to do simple linear regression. We will end up having similar thing here. So for us to do simple linear regression, we are going to data, go to data analysis. Those foundational stories for regression are very important because it's not just about producing the results, but it's about the results making sense. So for the results to make sense, you must have the background of regression. Why regression analysis? Okay. So you go to data tab, go to data analysis, click on the tool, and then select regression, click on OK, and then come here. Once you are here, under input y range, you select the dependent variable. Unlike in correlation where you just select everything, in regression analysis, you must specify which variable is the dependent variable and which one is the independent variable. So, in this case, we are using recovery time, which is our independent variable, which is our dependent variable. It depends on all these other things. The time the person is going to recover, maybe the age of the person. We are trying to assess if it depends really on those things. That's what we are doing here in regression. And when it depends on that, then our model will be significant. Our model will be significant. That's the term we use to say. So you come to input y range, select recovery time from here to here. Select including the title, recovery time, days. Then under x range for the independent, you select medical adherence score. You just want to assess the same thing. Select the medical adherence score like that. And then check that our data has labels. That means that we selected with the names for the titles, for the columns. And then sometimes we have something we call confidence level, but we are not going to cover that today because we are going to complicate our analysis. Confidence level, confidence interval, like to what % are we confident with what we are making a decision about? That's what confidence level is about. So from there, I think after you have done that, you click here, and then, yeah, if you want to assess, yeah, some assumptions of regression analysis. Regression analysis has 5 assumptions. So you can be able to assess those assumptions before you go ahead but one of the assumptions that is that the relationship must be linear between the two variables. So I am not going to assess normality. I'm not going to assess the independency of the observation. Of course, observations are independent here. I'm not going to assess the homoscedasticity, which is about equality of variance. So we are not going to assess all that. So we are just going to produce the results, but you should consider that when you are producing any regression results. Consider 5 assumptions of linear regression. Okay, so once you select this, select where you want to see your output here under new worksheet. Under new worksheet. Okay, sorry, under new worksheet, let me say I want to produce, not new worksheet, go to output range. Yeah, output range. Then I want to select where I want to see my results. So I just want to see my results near here. You can select anywhere. You don't have to select where I'm selecting. You can select anywhere for your output range. And then you can click on OK now. You can click on OK for you to see your summary simple linear regression analysis. Yeah. I want to know if we are there. I want to know if we are all there. I want to know if we are all there. Before we start talking about figures, you know, in data analysis, producing is not the problem. The problem is making the values make sense. So that's what we want to do here. So I want to ensure that we are all together before we start making sense out of the data that we see here. So are we together, colleagues? Yes? Can see someone?
Mine, when I
Yes.
click OK,
Yes.
it's saying X and Y range must have the same number of rows.
Okay, yeah.
I have
So
done so, but I can't see.
okay, no problem. Someone else? Okay, is everything all right? Can I see thumbs up for others who are okay with where we are so far? Okay, thank you. Thank you. Okay, thank you. So let me stop sharing and allow Dida for you to share your screen so that we can solve that before we proceed. Dida, if you can share your screen. If you can share your screen. Dida, are we together? We can't see your screen. We are waiting for you so that we can be together in interpretation. Can someone hear me? I don't know if I'm the one who is not loud. Okay, Dida?
Can you see my screen?
Yeah, I can see. We can now see your screen. Okay.
So this is the range I selected. This once I click OK.
Can you check input X range? F it is you selected F what?
F3 to F32.
Yeah, so you should change it to F2. Change it to F2. It must be a pair of observations. Must be a pair of observations. Yes. Thank you so much. And Dida, I want to use your screen now to interpret the results. So because we have the same results, I'm not having different results. So just share your screen. I'll use your screen to interpret. Yes. Just share your screen. I'll use your screen to interpret. Okay. Thank you. So we can be able to see that we have summary output. And then the first table we see is regression statistics. So if you can just expand that, go to the top between I and J. Go to the top of the columns. Go to the top of the columns. Yes, between I and J, and then drag. Yes, thank you. up to there, so it's okay. So multiple R, that's what we call Pearson R. So Pearson R value here is 0.8951. It's the same value that we got while we were carrying out correlation between the two variables. So it's what we call Pearson R value. So in this case, I can't see why you are, let me just check mine. I don't know what happened there, because the multiple R value is supposed to be with the symbol. Yeah, so that's why it's called multiple here. So it's multiple, so it's either positive or negative. So it is assumed here, but it's supposed to be negative. It must have a symbol for negative. So it must have a symbol to show that that relationship is negative, the way we had in the previous session, in the previous video, the previous class. So just ensure that you assess that using correlation first before making the decision. That's why it's called multiple R there. So it can either positive or negative, but it's supposed to be just Pearson R. Yeah, so then we go to R squared. We interpreted that 80.13% of time in terms of days has been explained, duration has been explained by the medical adherence. And then from there, adjusted R square. So we usually have noise. We usually have noise in our data. So for us to mitigate noise, not noise, but noise in terms of some adjustments. That's why you see things like standard errors and so on. Yeah, so adjusted R square is usually the most appropriate in interpreting the coefficient of variation, which is about 79.42%, 79.42% of our data, of our dependent variable has been explained by the independent variable. So when you have R squared different from adjusted R squared, use adjusted R squared, because it has mitigated noise in your analysis. Standard error is just the errors due to chance, so you don't have to consider that unless you are asked to also provide the standard error for your analysis. Observations, we have 30 observations. I'm not going to use analysis of variance table, because that one is another topic on its own to discuss about analysis of variance. So we are not going to use ANOVA table to interpret these results. But in this ANOVA table, we usually look at the sig value, significance value, the far end value, and and the F statistic value, the values that we see there, F statistic value and the F sig value. So the sig value, we usually compare it with a particular threshold value, which we usually call P value. If you are from the probability, maybe statistical background, you understand these things I'm saying. So significant value here, this value you see here is a very small value. So usually compare it with 0.05, which is usually the default. You remember where we were talking about confidence level? 95% confidence level, it was there by default when we were trying to produce the results. Yeah, so that's what that value does. So you can change the confidence to something like maybe 99% confidence, maybe to 90% confidence. So that is actually another topic on its own. We usually cover it in our different data tools that we usually train. Yeah, so we usually discuss about all those other things. But in this aspect, we are going to focus on the coefficient of on the coefficients. So analysis of variance is another topic on its own, so we cannot be able to discuss it right here. So that significance value, when it's less than 0.05, that value is very small. You can see it's exponential, negative, something. Very small value. So when it's less than, that means that our model is significant. What it means is that our model is significant. We can rely on it in making prediction. So we go to coefficients. So you can see these values, we already have them on our scatter plot. These values you see here, intercept is this constant, the one we were calling C is the constant. So that means that when, yeah, is that value you already have there. Yeah, you see those values, that model is already there. So that, what does that mean? That means that when someone has even adherence score of 0, the person is expected to take a constant of 40 days for recovery. 40 days for recovery. That is the anticipated. When your medical adherence score is 0, you are expected to take to take 40 days for you to recover. This is just because of the data that we have here. It's not personal to anyone, but it's just because of the data that we have here that we are using to analyze that. So it's not personal to anybody. So don't take it personal. If you are not adhering to any drugs that you're taking, so it's not personal in any way. So you're just saying that when your medical adherence score is 0, you are likely to take 40 days for you to recover. Okay. Then now we go to medical adherence coefficient, which is negative 2.989295272, and so on and so on. So what does this mean? This means that a unit increase, this means that a unit increase, a unit increase in medical adherence score causes the duration time for someone to recover from a medical surgery, causes the medical medical days of recovery to decrease by negative 2.989. To decrease. Once I say to decrease, I don't expect to mention the word negative. So once I say decrease, I don't have to use negative value in interpretation. So when I say, remember here, I will repeat, a unit increase in X causes Y to decrease by 2.989. I don't have to mention negative, just no negative is there because I mentioned decrease. Okay. So what does that mean to the case study that we have here? We are discussing about a health case study about time recovery in terms of days that someone will take after surgery. And then we are considering the adherence score to the drugs that the person is going to be given. And now we are trying to understand what is the relationship. Yes, it's negative relationship. One increases, one decreases. And then how strong the relationship? We see it was negative 0.89 something. And then can we be able to predict based on the historical data that we have? That's what we are doing here. So that's what those coefficients do. And we will be able to do a demo on prediction using Excel just here. And then we can now proceed to multiple linear regression. So up to there, before you use the coefficients, we have something we call p-value in that table. Remember, we have standard error, we have t statistic. These are values that usually accompany the results. When you are doing your analysis, you need to accompany these results interpretation. But the values that are very, very important and reliable is the p-value that you see there. The coefficients are very important. The p-value is very important to tell us if the variable you are considering was significant in the model. If you are building even a multiple linear regression model, you must assess and check, hey, are these variables I'm including in my model significant? If they are not, drop them. Remain with only variables that are important, so that your model can be fit, can be a good model, Okay, so up to that point, I would like Dida for you to stop sharing your screen so that I can go to my screen and show you how we can do a prediction. Yeah, so maybe there is a question. Yeah, can I see some reactions from members if we are together before we go to the prediction and then we go to multiple linear regression? Is there a question? Is there a question? Okay. Okay, we can now proceed to, let me start sharing my screen now so that we can do a prediction and then we proceed. Because once you understand simple linear regression, multiple linear regression is simple. Yeah, multiple linear regression is simple once you understand simple linear regression. Yeah, so I am also having the same results as you already have because Now we want to predict. Remember, we have a scatter plot here, and we have same model. We have same model. We have same model. So this model that I have here is the one I want to construct. This model I have here is the one that I want to construct. This model, I want to construct it here for me to be able to predict. So I will say, so remember here is where we have Y. Here is where we have Y. So for example, we want to predict the 31st patient, with the particular health record. So we say equal to, and then we start negative 2.9893 multiplied by X. Remember, X is this cell known as medical adherence score. This cell here. So I click on this cell, so that anytime I put that their value, I can be able to predict what will be the other value for the time duration that will be taken, plus 40.708. These values, if you don't produce a scatter plot, you will not have this model. You will just write that model from these values. It's not necessary to do this, but of course you can. Why not? Why not? And then once you have this, now you can be able to predict. This is just the same as what we have here. So when I will press enter here, you see now when this is 0, we expect someone to take 40 days to recover if the medical adherence score for the person is 0. Suppose the medical adherence of a person is 1, you see, when 1 increases, 1 is expected to decrease. You see, time taken, time duration for the recovery actually decreases to 37. Suppose someone medical adherence score is 5. We expect this person to take 25 days to recover. Suppose it is 7. We expect this person to take only 19 days to recover. Suppose it is 9. We expect this person to take a normal of 13, an average of 13 days to recover from that health surgery. And then if it is 10, then someone is expected to take 10 days. So the maximum, the minimum, sorry, the minimum days a person can take to recover is 10 days. It's 10 days. Based on this data, only when we are focusing on the medical adherence score. We have not included other variables. Okay. And the maximum is 40 days. Someone will take 40 days when his medical adherence score is 0. So up to there, can I see if we are together? If we are together in terms of prediction of simple linear regression and also understanding simple linear regression. Can I see if we are? Can I see if we are together? Anyone who is lost? Anyone who is lost? Anyone who is lost? Anyone who is lost? Faith, are we together? Dida, are we together? Nancy, a repeat prediction. Thank you, Dida. Nancy, are we together? Okay. Nice. So I'll repeat prediction. So I'll go to Excel. So here, I'll delete everything. I'll start afresh. Sorry for the background. So remember, we are considering two variables. The first variable is recovery time in terms of days. Recovery time in terms of days of a patient after undergoing surgery. And then we are trying to predict based on the medical adherence score. The medical adherence score, we gave a score of maybe 0 to 10. And so we want to understand where 10 means that this person is 100% adhering to the medical scores, medical adherence, to the drugs. While 0 being, this person is the one who only likes injection and not even drugs or something like that, or even injections can also be part of the medical adherence score. You may fear to be injected and also at the same time fear to take drugs. So we are predicting about you. So, so we can say equal to, so we are building this model. So we say equal to negative 2.989 multiplied by x. X here you refer to a cell that you will be inputting the values. You see, you'll be inputting values for the medical adherence score to see, oh, this has changed to this has changed to this, and so on and so on. Remember, this is another patient. We don't know. We don't know how long this patient is going to recover. We want to predict how long this patient is likely to recover based on the adherence score of the patient. Okay? And then we add the constant, the intercept 0.708. And then now we predict. You see, when this is 0, this is equal to 40.708. When this is 1, when the medical adherence score is 1, this decreases. That's what we said here, the kind of relationship. You can see how it's now helping us here. So, and so on, and so on, and so on, and so on. So you can have another patient, you can have another patient, you can have another patient, and so on. And you can be able to predict this by dragging it down like this. And you can be able to predict how long are these patients going to take to recover based on their scores, and so on, and so on. Are we together now up to there? Are we together now up to there? Are we together now up to there? Dida, are we together now? Are we together now? Are we together now? So that's now we can go to multiple linear regression. We can now go to multiple linear regression. And multiple linear regression is going to be our last session. That means that the t-test hypothesis testing will be covered in our next challenge. Yeah, so hypothesis testing will be covered in the next challenge. So worry less. We'll just have to understand what it is, and then we will do the practicals in the next challenge. Next challenge is starting next week, Friday. Next week, Friday. So if you are here for the first time, you have an opportunity to do that. So let me clear here content. So maybe this is simple linear regression. Let me create a new sheet. Let me create a new sheet so that I can have totally new things. Yeah, so let me just copy this data to the new sheet so that I can do the multiple linear regression. So I can just copy this data. This data, you select the data, Control C to copy, then go to the new sheet, then Control V to paste. Then you paste your data. Control V to paste your data. So I have a new data here, the same data in a new sheet. And now I want to do multiple linear regression. So the basis of multiple linear regression is that it builds on top of simple linear regression. Suppose you try to build a model and you come to realize that the model is not a good fit. You see, it's lacking some other predictors. We call them predictors. So you have to go and look for other missing variables. So that is what we call assessing the validity and the reliability of the model. That's machine learning knowledge. So here, we want to do multiple linear regression. So for us to conduct multiple linear regression, we are going to consider age. We are not going to look at this other thing known as gender. We are not going to consider gender in this. We leave out gender. So we are going to just focus on these numerical aspects. So if you want to deal with gender, you can also do that using other data tools like SPSS, Stata, R, Python, and so on. So here we want to start by also checking maybe random relationships between physical therapy duration. I think I'm not going into that. You can later go into that and check the relationships between this and this, relationship between this and this, maybe relationship between age and the recovery time. Maybe that one is very important. Let me see how it can help us understand this. So we'll just go to correlation. I'll go to data, go to correlation, data analysis, correlation. I'll go to correlation. I just want to understand the relationship between age and how long will the person take to recover. So I'll remove the existing historical procedures I followed, and then repeat here. So I start by the input range. So the input range here, what I'm going to do, because these rows are located in different locations, I cannot just highlight everything here. So what I will do, I'll come to take this edge is the far end, so I'll just take edge like this, select edge like this, and then press on control, don't release control, press on control, then go to recovery time, don't release control, and then also select this recovery time, so that you can only select the two variables. Then you can now release control. You can now release control. You first of all select edge. While holding control, go to recovery time. In terms of days, also select it. And then now you can check data has first row has labels. And then the output range, maybe we want the output range here. And then you select output range. You change it here from new worksheet to output range, then click here, and then go and select where you want to see the output range. Then click on OK. The correlation output must be contiguous. Okay. Yeah, it's telling me that it must be contiguous. So that tells us that we have to copy this and now put it on at the same place if we want to assess with the correlation. It does not want us to select from different locations. So let's just put these two variables together by copying and pasting age and recovery time together like this. And then now I can now repeat the procedure. Data analysis, correlation, click on OK. I'll now delete this because it was refused. So I delete this and then now select my data. I can drag this and put it somewhere else. And then now select my data. So this one I can just, here you select everything. You don't have that this is X, this is Y, because this is just correlation. So we are doing correlation. So check on the row, first row has labels, output range, select the output range that you want. So I'll change this and maybe select here like this. And then you click on OK. So you just want to check the relationship between age and the recovery time. So what does this mean? This one is lying to us. Maybe this one is just because of the, it's not lying to us. It's just true based on the data that we have here. So it is not actually generalization of what is actually in the field, because this is just a sample data anyway. Don't take it to another level. We are saying that as age increases, that is the recovery time of the person is also increases. And it's true. It is true, actually. It actually depicts what is in the field. And that actually, once someone is old and undergoes surgery, it will take that person more time to recover compared to a young individual. Yeah, so it is actually true, but I don't have that fact anyway, based on this data. This is what I'm relying on as my lawyer. This is my lawyer. So this is what we see. We discuss about correlation. So this value ranges between -1 and 1. So when it approaches 1, that means a very strong positive relationship. So as 1 increases, 1 increases. You can even see that using a scatter plot. You can even see that using a scatter plot. You select the data range, go to insert. We already carried out these processes, so that's why I'm doing it faster. And now you can see the kind of relationship that is here is positive, unlike the one we had previously. And then you can click here and add a trend line if you want, yeah, and so on. Yeah, and we can also add a model if we want to predict. Anyway, you can do that later as you're part of learning. Yeah, so we have covered that now. So we can now proceed and do multiple linear regression. We can now proceed and do multiple linear regression. So for us to do multiple linear regression, we go to data analysis, go to regression, scroll from correlation to regression, scroll from correlation to regression, and then click on OK. And then now here, delete everything that you see, delete everything because it is just having history of what we did last. So just delete everything and now select afresh. So begin here because here we have to specify Y and specify X range. So Y range is the dependent variable, the variable we want to predict, which is recovery time in terms of days. So you select this one like this up to here, and then X range, you select everything that is remaining, everything, because it's multiple linear regression. Select everything that is remaining, like that, like that. Select everything that is remaining, like that. So if you want to assess again, simple linear, to assess regression assumptions, normality, linearity, this data must be linear, independence of observation, constant variance, which we call homoscedasticity, and normality. So you can have plots here to help you assess that. But now for us, we are producing the results just for interpretation. You can also go and learn more about the basis of those assumptions. And then you can click on where you want to see the output. Click on where you want to see the output. Maybe I want to see the outputs here. So just be keen so that it does not overwrite anything that you already have. So just put somewhere else because it usually writes down like this. And then from there now you can click, check that your data has labels. If you don't check this, it will tell you that we have non-numeric values in your output. So here is what we call confidence level. So you can check that and check and change based on the research study that you're doing or based on the analysis you're doing. But in this case, it will be 95 by default, even if we don't check here. It will be 95%. That is 5% significance level. So we usually talk about those terms in the other classes. So yeah, so just click on OK to see your output, So we are not going to talk about the above values. We can just discuss on the adjusted R square because it actually tells us to what percent of our coefficient of our dependent variable has been explained. You see, in simple linear regression, we only had around 79 point something percent under adjusted R square. Now we have added other variables to our model. And this now is very interesting because now you have added other models to it has now adjusted. our coefficient of variation has adjusted from 79 to 94. Actually, it is 94.26% of our dependent variable has been explained by the independent variable. That makes the model more reliable, makes our model more reliable. We said we are not going to interpret the analysis of variance table. We usually cover that one as a particular topic on its own. So we are just going to look at the predictors here. Yeah, but now what we see, look at the p-values, means that these values are all, there's someone who wants to talk, please, you can unmute and talk.
When I click OK, mine,
Yes.
my multiple linear regression is not coming to the screen. It's saying regression input range contains non-numeric data.
Yeah. So that's what I was saying, that under data here, go to data analysis, and under regression, check these labels. Ensure that this is checked. This
It
box,
is checked.
check if it is checked,
It is checked.
and then you click on OK. Oh, sorry, I have output there. So just I will cancel for my case because I already have output here in the output range. Yeah, so for you, ensure that the range here, I just need to confirm that. So maybe you'll allow me to interpret and then allow you to share your screen if you still have a problem. Just ensure that the y-axis, the y range is reading, you have your own range here, but just ensure that the first row is the one that contains the names. And then the other rows are numeric, just based on what we have selected. And then also on X range, also do the same. And then click on OK. Then click on OK. So maybe before I interpret, I will allow you to just share your screen before I interpret so that we can move together as we reach to the final of our session today. So I'll stop sharing here so that you can share your screen, so that we can handle that right away before we interpret. Okay. So just uncheck confidence interval, uncheck confidence interval, and where is your dialogue? Okay. So where do you want your output to be? Okay, there is where you want your output to be. So let's go to the ranges. So to the ranges, we see that, scroll down. Why do you have total down there? So let's proceed. Just leave that. That's the prediction. Okay, let's proceed. 32. Okay, the other one. Okay, I see. I think that is where you now have problem. Yeah, you need to select age from age. Select from age to medical adherence. We left out. No, select with the titles. We left out gender and patient ID.
Oh,
so
okay.
select that to that end, and then you click on OK. Regression input range contains a numeric. Click on OK. Click on OK. We see again. G. Okay, you have to check that. Okay. So what is G? What is that range for input X?
G1 to G32.
And the other one?
C2 to F32.
So we expect it to read from C1. We expect it to read from C1. We expect it to read from C1. Yo, you still have challenges. So let me see. Let me see. Cell. I think you are. Let me see. Can you scroll up? Can you scroll up? I think there is an empty cell.
Where?
Can you scroll up to the first row? Yeah, you see there's an empty cell and you are selecting it. I think you're including it in the range. So can you just select afresh? Can you just go to the data analysis? Go to the data analysis and then go to, yeah, okay. Go click on okay. And then select from A, you see there, it should be A2, not A1. So just change everything. Just click on, no, just go back to the dialog. Let's go back to the dialog. So just change from 1 to 2. I think you have blank. That's why it was telling you non-numeric. So just change G1, change from G1 to G2, and then from C1 to C2. Yeah. Then from C1 to C2. Yeah, like that. And then you click on OK. C1 to C2. Yeah, just that. Then you click on OK. Yeah. Okay.
Thank you.
So there you go. Yeah. So yeah, you will stop sharing so that I think I will just share mine so that we can now finalize. Just stop sharing. Okay, thank you. So I'll now share mine and interpret, and then we'll be good to go. We'll be good to go. So here, you see, we have p-values here. So these values, any value that will be greater than 0.05, a value that will be greater than 0.05 is termed as not significant. So that means that physical therapy duration is not significant in our prediction. Physical therapy duration is that number of visits that the doctor or a therapist can visit you to give you advices. Oh, you know, you are going now to the surgery. Now you need to relax. You need to, yeah. So we are being told here that actually that one is not one of the most interesting things in the prediction of this. So we have to drop it. But however, that will mean that we have to reproduce the results by not including it. But now we are not going to do that in this case. We are going to ignore that. But for your case, you need to ensure that when you're doing analysis, you are keen on this. Depending on the percentage here, by default, is usually 95%. So you will just ignore, but you will have to drop it when you want to take these results to another level. And then now we will build the model. We will build the model the way we had the model, the other model, previous model. So for us to build a model here, I'll just build the model right away. Let me see where we are. I'm just seeing some things here. I will just need to drop some of the things here. So I'll just drop this so that they don't make a lot of noise to me. You know, they are making noise. They are making a lot of noise to me. So I need to see this other end easily. So I'll just minimize the number of empty cells I have, empty columns I have. Yeah, so I want to build here the model right away so that it can be easier for us to understand. So we want to build the model here, multiple linear regression model. So we say equal to, remember, for multiple linear regression is y is equal to a plus b1, b1 x. Remember, there's times here, b1 times x, plus b2. B2, usually call them beta naught, beta 1, beta what? Yeah, you will meet that when you want to learn machine learning or data analysis in depth with other tools. You'll meet that. You must meet that. So this is x1. You call this x1. So you come here, beta 2, x2, and so on, plus beta 3, b3 times x3, and so on and so on. So this is what we want to build. Remember here, beta 1, beta 2, beta 3 are the coefficients, these values. And then x1, x2, x3 are the variables, these variables. A is the intercept, So that's what we want to do here, colleagues. So we are going to say equal to, of course, this is the y. So you say equal to, A is the constant, which is 20, 20.77, 20.77997, and then plus 20.77997. And then we now add the edge. The first variable is edge. So edge is this other end. So we'll just say we put the value for edge, coefficient for value of edge is 0.175. I can leave it to that significance level, to that significant figure, and then multiply by what? This cell. And then proceed plus, because this is plus here. And then now the next one is minus. The next symbol here is minus. So I'll have just to say plus minus, or I can just say minus, because plus minus is minus. If you will allow me, but I will use plus minus. But let me just use minus, because plus minus is minus. So 0.8925, something like that. And then I'll click on plus, sorry, not plus, times, and then I select this cell. You see how I'm selecting? Select that cell, and then go to the next one is plus. Plus 0.009. You see, it is not even significant. You see, even the coefficient value is very small, it has no impact. You can drop it, but let's build with it in the model anyway. So 4, 3, 8, and then multiply by. We go, you select this cell. The last one, you say plus, minus, which is just minus 0.77461. And then you multiply by this cell here. Multiply by this cell here. And then from there now you are ready to predict. So this, what does this mean? This means that when other variables are not included in the model, someone is expected, the average time for someone to recover is 20 days. Average time someone is expected to recover is 20 days. When we don't include all these other variables in the model. And then when we include age, so keeping all other variables constant, keeping all these other variables to 0, a unit increase in age causes time duration to increase by 0.175. That's how we interpret that. This one is that a unit increase in, this one was what? Pre-surgery score. Yes, pre-surgery score. Unit increase in pre-surgery score causes number of days to decrease. Number of days for recovery to decrease by 0.8925. And so on and so on. That's how we interpret regression models. And then you press on enter here. And now you can put here values for any other patient. And now you can be able to automatically predict. Let's say we meet a young man with 30 years. And then maybe the pre-surgery score for this patient is 7. And then the physical duration, therapy duration is maybe on average is 20 hours. And then medical adherence score of this patient is 5. So how long will this patient take to recover? It's going to take this patient 16 days to recover. So that's what we call prediction regression model, and that is it. So unless there is a question, that marks the end of our session. So I'll be sharing the evaluation form in the chat section so that we can evaluate how significant was our session. And unless you have a question, so once you get the feedback form, you just need to help me. You just need to help me indicate if you're already in our groups. If you are not in our groups, please, we would like to add you in our groups because we usually have different programs like this that can help you elevate your data skills. So can I get some comments on how the session was? And maybe from there, we can now be able to fill the feedback form that